This is the 1973 free response question for solutions. If you haven't done this problem on your own yet, I highly recommend that you stop or pause this video, go do the problem on your own, come back and see if you got an answer similar to mine. As this question is from 1973, it has no scoring data and therefore is worth 1 point, 2 points. I can estimate what your points would be worth for the question. I'm thinking this question is worth 2 to 3 points maximum, and therefore it's a pretty short question. Something along these lines is more likely to appear in a multiple choice than it is in a free response nowadays. But here's your practice for writing. The more writing practice you get, the better you are off. So the molar solubility of silver bromide, and I might want to write silver bromide's formula. All right, silver plus 1, bromine minus 1, 1, 1, they cancel out, is diminished by the addition of a small amount of solid potassium bromide to a saturated solution. I bet you I'm going to have to explain why. However, the molar solubility of silver bromide is increased by the addition of solid potassium nitrate. Another one I probably have to explain why. A salt whose ions are not common to those of silver bromide. Dun, dun, dun. Explain these experimental observations in terms of the principles involved. All right. So first off, I have silver bromide. Halides are insoluble when paired with silver, mercury, or lead, but you know from the equilibrium unit that they are, nothing is completely insoluble. It's going to establish some sort of equilibrium. And even if that number is very, very small, you are going to end up with an itty-bitty amount of silver ions and bromide ions in solution. So if I add potassium bromide, that's like adding a stress to the system. I've added potassium bromide. The system's going to favor the production of more silver bromide. So this is simply Le Chatelier's principle. So now I need to explain that first statement, that first concept to my grader. So silver bromide, solubility decreases with the addition of potassium. Yeah, start off writing sodium. Potassium bromide because potassium bromide adds bromide ions to the solution, thus causing, and the big word there, when you add an ion that has in common with your insolubility one, you call it the common ion effect. Causing the common ion effect, which causes the equilibrium to favor the production of more silver bromide. And we might even say this is Le Chatelier's principle. And you could just abbreviate. You could say, according to Le Chatelier's principle, you could just put in parentheses and say, I'm citing Le Chatelier's principle. All right, so that's one observation out of the way. Observation 2, it's a little hairier. It says the molar solubility increases with the addition of solid potassium nitrate. It's an ion, it's a salt whose ions have nothing in common with silver bromide. So what's happening here? Okay, well here's my solution. No. I have silver. I have bromine down here, and it's, come on, no, I don't want that. There we go. It's in its solid form. If I add some sodium and some nitrate, what's happening here is that sodium can attract that bromide ion just as well as the water can, and the nitrate can attract that silver ion just as well as water can. And what actually happens here is something called the diverse ion, or uncommon ion effect. So we have to explain that to our grader. Now, if you have never heard of this before, is because this, I do not believe, is something we still teach to students because it just muddies the water. So if it's something you've never heard before, just be satisfied with you got one of the two possible points, which is more than enough. So if I was going to express the diverse common ion effect to my grader, I would start with, as sodium nitrate is added to solution, the sodium ion can attract bromide ions into solution, and the nitrate ion can attract silver ions into solution, therefore increasing molar solubility of silver bromide. And I might even say I'm citing the uncommon ion effect. I don't want to tell you don't need to know it because I do not write the AP exam, but it's one of those things that has fallen by the wayside. So if I were to assign points, because I have that type of power, mahaha, which I really don't, I would assume this question is probably worth 2 points, 1 point for making reference to the uncommon ion effect, or at least being able to explain it, and then 1 point for talking about the addition of bromine or bromide causing a shift in the equilibrium, so citing either the uncommon ion, the common ion effect, or Le Chatelier's principle. So 2 possible points, 1 out of 2 is a pretty decent score.